The solar system is not a collection of frozen worlds suspended in silence. It is alive with motion. Planets pulled endlessly by gravity, ancient debris left behind from violent formation, comets wandering inward from the darkness beyond Neptune, asteroids crossing invisible paths carved over billions of years. Every world tells a different story. Some became frozen wastelands. Some were shattered by impacts. Some still hide oceans beneath ice, and some changed completely. Closer to the sun than Earth, wrapped beneath thick clouds that reflect sunlight like a beacon in the night sky, Venus was once imagined as a tropical paradise, a world of oceans, rainstorms, maybe even life. Instead, it became something else, a planet where the atmosphere crushes spacecraft within hours, where temperatures melt lead, where the surface disappeared beneath poisonous clouds and volcanic plains. Venus is Earth's closest planetary twin, and one of the greatest warnings in the solar system. Venus is often called Earth's sister planet. At first glance, the comparison makes sense. Venus is only slightly smaller than Earth. Its gravity is close enough that a human standing there would barely notice the difference. Its rocky structure formed from many of the same materials found on Earth. But everything changes at the atmosphere. The sky of Venus is hidden beneath an enormous blanket of carbon dioxide nearly 100 times thicker than Earth's atmosphere. Above it float dense clouds of sulfuric acid. No blue sky, no visible horizon from orbit, no sunlight reaching the ground clearly, only heat. The pressure at the surface is crushing, equivalent to being nearly 1 kilometer beneath Earth's oceans. And the temperature, around 465 degrees Celsius. Hot enough to melt lead. That makes Venus hotter than Mercury, even though Mercury is much closer to the Sun. The reason is simple. Venus trapped its heat and never let it escape. Yet despite its nightmare conditions, Venus remains one of the brightest objects in Earth's sky. Ancient civilizations tracked it for thousands of years, sometimes appearing before sunrise as the morning star, other times glowing after sunset as the evening star. It shines so brightly because its thick cloud layers reflect enormous amounts of sunlight back into space. Beautiful from a distance, catastrophic up close. Before spacecraft reached Venus, scientists imagined something very different beneath those clouds. Because Venus is so similar in size to Earth, many early astronomers believed the planet could be habitable. Some imagined vast oceans hidden beneath permanent cloud cover. Others pictured jungles, swamps, or even alien ecosystems evolving under dense atmospheric conditions. Science fiction embraced the idea completely. In the early 20th century, Venus was often portrayed as a tropical world teeming with life. At the time, nobody could see the surface. The clouds hid everything, and from Earth, Venus looked strangely alive. Its atmosphere moved dynamically. Its brightness shifted. Its thick cloud systems hinted at weather and climate. But radar observations in the mid-20th century began revealing something unexpected. Venus was extraordinarily hot, far hotter than it should have been. When the first spacecraft finally arrived, the dream collapsed completely. No oceans, no rainforests, no living paradise. Instead, Venus revealed itself as one of the most hostile environments ever discovered. Yet the similarities to Earth remained unsettling. Same general size, similar internal structure, likely similar beginnings, which raised a terrifying question. If Venus and Earth began so similarly, what caused one world to survive and the other to become hellish? The answer lies in climate, more specifically, a runaway greenhouse effect. On Earth, greenhouse gases like carbon dioxide help trap heat and keep the planet warm enough for liquid water and life. Without them, Earth would freeze. But on Venus, the process spiraled out of control. Scientists believe Venus may once have possessed shallow oceans billions of years ago. Back then, the young sun was dimmer than it is today. Conditions may have been far more stable, but Venus orbited too close to the sun. As solar energy increased over time, more water evaporated into the atmosphere. Water vapor itself is a powerful greenhouse gas. More heat caused more evaporation. More evaporation trapped more heat. The cycle accelerated. Eventually, the oceans may have boiled away completely. Ultraviolet radiation from the sun then broke apart water molecules high in the atmosphere. Hydrogen escaped into space. Oxygen reacted with surface rocks, and Venus lost its water permanently. What remained was carbon dioxide, huge amounts of it. Today, Venus's atmosphere is more than 96% carbon dioxide. The greenhouse effect became unstoppable, and the planet transformed into a furnace. This is why Venus matters so deeply to planetary scientists. Not because Earth is becoming Venus tomorrow, but because Venus shows how climate systems can fundamentally reshape a world. Planetary evolution is not guaranteed to remain stable forever, and Venus proves that even Earth-like worlds can become unrecognizable. Getting to Venus is difficult. Landing there is worse. The Soviet Union became the first nation to truly explore Venus with the legendary Venera missions. These spacecraft descended directly through the atmosphere during the 1960s, 70s, and 80s. Some failed instantly. Others survived just long enough to send back humanity's first images from another planet's surface. The pictures were shocking. Flat rock fields beneath an orange sky. No movement. No life, only heat and pressure. Many Venera landers survived less than an hour before being destroyed by the environment. Electronics overheated, pressure crushed components, systems failed rapidly, yet they changed planetary science forever. Then came NASA's Magellan mission in the 1990s. Because Venus is permanently hidden beneath clouds, normal cameras cannot map the surface from orbit. So Magellan used radar. The spacecraft revealed enormous volcanic plains, mountain ranges, impact craters, and vast geological structures hidden beneath the atmosphere. More recently, Japan's Akatsuki mission began studying Venus's atmosphere in extraordinary detail. It observed immense cloud movements and atmospheric superrotation, where upper winds race around the planet far faster than Venus itself rotates, and exploration is far from over. NASA's future missions, Da Vinci and Veritas, aim to study Venus in greater detail than ever before. Da Vinci will investigate the atmosphere directly. Veritas will map the surface with advanced radar systems. Scientists hope these missions may finally answer one of the biggest questions in planetary science. What exactly happened to Venus? Venus may still be geologically alive. Its surface is dominated by volcanic landscapes. Huge lava plains stretch across enormous regions of the planet. Massive shield volcanoes rise from the terrain. Some are larger than any volcanoes on Earth, and scientists now suspect some may still be active today. Radar observations have revealed possible changes in volcanic vents between different missions. Atmospheric measurements also hint at recent volcanic activity, but confirming active volcanism on Venus is difficult. The atmosphere hides almost everything. The surface itself remains one of the most extreme environments ever encountered. The Soviet Venera landers barely survived. Metal weakened rapidly under the heat. Electronics failed quickly. Pressure pushed every engineering limit. And yet, despite these conditions, Venus remains strangely Earth-like in shape. Mountains, volcanic plains, tectonic features, a familiar planet transformed into something alien. Venus exists deep within the Sun's influence. Closer to the star than Earth, it experiences solar activity far more intensely. Solar wind particles slam constantly into the upper atmosphere. Without a strong magnetic field like Earth's, Venus cannot shield itself effectively. The Sun strips atmospheric particles away over time, and occasionally wandering objects from the outer solar system pass dangerously close. Near-Sun comets, sometimes called sun grazers, plunge inward from deep space, heated violently as they approach the Sun. Some disintegrate completely. Others survive briefly before breaking apart. Asteroids also cross the inner solar system, moving between the orbits of Earth, Venus, and Mercury. Over billions of years, impacts likely helped reshape Venus's surface repeatedly. Venus exists in a harsher neighborhood than Earth, closer to the Sun, more exposed to radiation, more vulnerable to solar extremes. And yet, despite all of that, it still remains one of the most Earth-like planets ever discovered, which only deepens the mystery. This remains one of the most controversial questions in planetary science. Did Venus once possess oceans? Many scientists believe it is possible. Some climate models suggest Venus may have maintained liquid water for hundreds of millions, perhaps even billions, of years before the runaway greenhouse effect fully transformed the planet. If that happened, could life have emerged? Right now, there is no confirmed evidence that life ever existed on Venus, but the possibility has not been completely ruled out. In 2020, scientists announced a possible detection of phosphine gas in Venus's atmosphere. On Earth, phosphine is often associated with biological activity. The announcement triggered enormous debate worldwide. Some researchers argued it could hint at microbial life high within the Venusian clouds. Others challenged the data entirely. Subsequent studies questioned whether phosphine had actually been detected at all. Today, the issue remains unresolved. What is confirmed is this: Venus still contains enormous scientific mysteries. Scientists do not fully understand its climate history, its geological evolution, or whether its surface is still volcanically active. And until new missions arrive, many of those questions will remain unanswered. Venus began as one of the solar system's greatest possibilities, a world so similar to Earth that humanity once imagined oceans beneath its clouds. Instead, it became something far more powerful, a warning, not because Earth is destined to become Venus, but because Venus proves that planets evolve, climate changes, atmospheres transform, worlds live and die over billions of years, and somewhere beneath those crushing clouds and volcanic plains lies the story of how one Earth-like planet crossed a line it could never return from. In the next chapter of Worlds in Motion, the journey continues outward once again, toward another world shaped by ancient water, violent impacts, and the search for life beyond Earth. If you enjoyed this journey through the solar system, don't forget to like and subscribe to Skyward Space Quest for more cinematic space documentaries.